Hello everyone, thank you for joining me. In this video, I will talk about a problem known as edit distance. It's also dynamic programming problem and Leetcode number 72. Before I start, let me thank all the subscribers and viewers for the past videos. That is a positive reinforcement of and encourages me to try more solving challenging problems. And let's first understand the questions. So it says, given two words, word 1 and word 2, find minimum number of operations required to convert word 1 to word 2. So we have to convert word 1 to word 2, and we have to count what is the minimum number of operation we can do to convert. So there is some restrictions on the operations. So only 3 operations permitted: insert a character, delete a character, or replace a character. So we can only insert a character, delete a character, or replace a character in the word 1 to get the word 2, and that will govern the minimum number of steps to reach word 2 from 1. Okay, so let's have some example. We have input, word 1 is horse, horse, and word 2 is rorse. So output will be 3. Let's see how we can get 3 from here. So we have horse, we replace h to r, which I'm showing by arrow. So now we have rorse, rorse. Now we delete the middle r, and we are now left with rose, rose, and then we delete the e and we got ros. So by manually doing, we did this thing to get the minimum number of operations to convert horse to ros. There can be more operations, but here our interest is only in finding the minimum number of operations, and that land us to an algorithmic perspective. Okay, so let's have another example which is slightly more complicated but still makes sense. So word 1 is intention and word 2 is execution, execution. So intention, intention being converted to execution. So here output is 5. Clearly the word is longer, and it might need to do more operations than just 3 in the previous example. So let's say how we can do it manually. So we can delete the t initially, and we got inention. The next step, we convert the first I to E, and we get enention, and then we replace the first n by x, and we get exention. Then in this step we convert the n to c, and we got exection. And here in this step we insert u at after c and before t. Between c and t we insert u, so it become execution, and we got the second word execution. And we see the arrows show 5 transformations, 5 operations, and we have the output 5. Okay, so we can get it using a dynamic programming paradigm. So in dynamic programming, we make a array dp 2D dp matrix, and this matrix has the number of rows equal to number of words in the number of characters in the word 1. So the number of rows will be 5 for the first problem, and number of columns is equal to number of characters in second word, which is ros. So for first example, we will have a dp matrix with 5 rows and 3 columns. And similarly for the second input, we have 1 2 3 4 5 and 4 9. We have 9 rows and 1 2 3 4 5 and 9 columns. So really big 9 by 9 dp matrix for input 2. That is why input 2 is little complicated. Let's try to look at we will see both input through the algorithmic perspective, and before going to implement it into program. So let's first look into the first question. So in first question we have horse, which all the characters we write them on the y-axis, and then we write ROS, which is the output, which is word 2 on the x. Now we have to convert this, so we make an empty in the beginning of first row and first column. So this empty means we are starting with the empty string. So when we start from empty string, how many operations we have to do to reach empty string? 0, right? Clearly 0. So if we are starting with an empty string, so how many characters, how many operations we need to get R? Only R, obviously 1, because we will insert R. So how many characters we will need to get RO starting from empty string? Clearly 2, because we will insert R, then we will insert O. And next, how many operations we need to get ROS from empty string? Clearly 3. So we see that in this DP matrix, each number shows that how many operations we need to convert all the value on the left on the y-axis to the value on the x-axis here, and all the proceedings are also included. So for example, for getting this 2, we include 0 O as well as R. For computing this 3, we have S, but we also include ROS, so getting ROS from empty string. Similarly, starting from H, we need one operation to get empty string because we have to delete H. For getting R, we also need one operation because we will replace H by R. For getting RO starting H, we need 2 operations because we can replace H by R and then insert O. And for getting S, we need 3 operations because we replace H by R and then we insert O followed by S insertion, so total 3. Okay, and now we try to pull values in the first column as well. So now starting we have HO as an input. How to get the empty string out of it? We need 2 operations. We delete O and then we delete H. So here we have 2. Now for R, we will consider the past characters as well. HOR, we have HOR. How to get the empty string? We have need 3 operations. We delete R, we delete O, we delete H, and that's why 3. So now we have S, so HORS, we have 4 characters. How to get empty string from this one? We need 4 operations: deleting yes, deleting R, deleting O, deleting H. And for HORSE, horse, there are 5 characters, and for getting empty string out of this input, we need to delete all the 5 characters one by one, and that's why here we have 5. Okay, so this is one thing. And here, after getting these 2 rows, the rows for the empty and rows for the first column, first character and both, now we use some transformations. So first of all, we have to fill the first value, which we have to fill is this one. So this is corresponding to R in the X and O in the Y axis. So for this, we try to see if O and R are the same. We compare O and R. If they are same, we don't need to do anything. We just take the transformation from one before. So if we found that 2 characters are same, for example, O here coincide with the O here, it means these 2 are same and we don't need to replace or delete O with anything. So if I have to get RO from HO, I only have to replace H by R. That is why we have 1. So whenever we have that the value corresponding to each row and column, they have same character, we copy the DP value from the diagonally opposite element. So this, if this is I comma j element, this will be I minus 1 j minus 1. So diagonally previous value. So for first this is our first value, this one. So getting R from HO, we need 2 values, and how we get it? We take the minimum of these 3, the top element, the diagonal element, and the left element. So left element is, if this value is ij, the left element is I minus 1 comma j, the diagonal element is this one is I minus 1 j minus 1, and the top element is I comma j minus 1. So I wrote these 3 here, and we take the minimum of these 3, and we take the minimum of these 3 and add 1 to is to be 1 plus minimum of 3. So minimum is 1 and then 1 plus 1 becomes 2. Clearly when we move here, we see that O and O are exactly the same, so we don't need to take anything, we don't need to transform O, we only have to go to one step earlier. So we copy the diagonally opposite element to here if the characters are equal, and if they are not, we take the minimum of top, left and diagonally opposite element and we add 1 to it. Okay, so now we have here below S, and here S and O are different clearly, so we will take the minimum of these three. So 1 2 3, minimum of these is 1, so 1 plus 1 becomes 2. Clearly when we come here, so R and R are same, so we don't need to transform them, we will copy the value from diagonally opposite to here and we have got 2. Next we have O, R and O are different, so we will take the minimum of these three elements, so 1 2 2, so minimum is 1, 1 plus 1 becomes 2. Next we have to get R transformed to yes, so they are different and that's why we will take minimum across 2 1 2, so it is 1 and 1 plus 1 becomes 2. Now the as we already have written the first column, so we will go for the second one. So S and R, they are different, so we take the minimum of 2 3 4, minimum is 2 and 2 plus 1 becomes 3, so 1 plus minimum if the characters are different, otherwise copy the diagonal element. This is a rule we will follow. So while for this one we have O and S which are different, so minimum is 2 2 3, minimum is 2, so 2 plus 1 becomes 3. Here again yes to yes, so both are same character, we will copy diagonally opposite elements, so 2 is copied directly here. The reason is because if both are same, we don't need to transform them, we just have to transform one previous value, and that's corresponding to I minus 1 j minus 1. Okay, and for E we'll calculate this value, the minimum of 3 4 5 is 3, 3 plus 1 becomes 4. For E and O, since it is different, the minimum is 3 and the final value become 1 plus 3 is equals to 4. For E and S, we have the minimum value equals to 2 and 2 plus 1 becomes 3. After doing it, we know that each point shows the amount of operation needed to convert the input corresponding to this character and the previous characters to the output corresponding to this character and previous character. For example, this 2 is the number of operation needed to convert R and previous character, which HOR to RO, the output and the previous one. So clearly this number, which is the last bottom right element 3, is the number of operation needed to convert E and previous elements characters, so horse, to S and previous characters ROS. So this is what we need, so we will return m minus 1 and minus 1 of this DP array, and this is our final answer. So I also made a complicated example here, and you can pause this video and try to make this array the same way I made for earlier one, and try to copy the diagonal elements when things are same. For example, here T and T are same, so we copy diagonal element. And in all the other cases, for example, here we take the minimum of this and this, so 5 6 7, minimum is 6 5, and we add 1, 5 1 plus 1 becomes 6. And I encourage the viewers to try to come up with this DP array using the same logic which I just explained, and compare your number with these numbers. It's very important that you get familiar with this approach and this strategy for getting the minimum number of operations. And now it's time to go through some code or pseudocode. So for edit distance, where we are trying to find the min distance which is required to convert word 1 to word 2. Both of the word 1 and word 2 are strings, and so string is basically a array or list of characters, and we have the int, which is the number of operation needed. So if the word 1 and word 2 both are empty, so not word 1 not word 2 means both are empty, we return 0 obviously. If not word 1, it means if the word 1 is empty, we return the length of word 2, because we have to insert all the characters of the word 2 one by one to go from empty to word 2. And if not word 2, if the word 2 is empty, for example, we have to return length of word 1, because then we have to delete all the characters in word 1 to word 2. So basically word 1 is our input and word 2 is our output. Okay, so now we got m is the length of word 1, n is the length of word 2, and we define a DP array to be minus 1 fully and of the same size with the number of rows equals to m, that is the length of word 1, and number of columns equal to length of word 2, which is n. So we define dp is equals to minus 1 times n. So we have a column, and number of columns, one repeated is many times there are columns, minus 1 times n. And for I in range 1 in range m, basically 0 to m minus 1 is the index for rows. So for all the rows we repeat this value, and we can also write dp 0 here. We so even 0 will also work instead of minus 1. So basically this is a placeholder for dp, because we try to find if dp is minus 1, we initialize dp to some value, and if that value is the initial value, we update dp, otherwise we don't update. So minus 1 I use because this is very distinct than 0 any positive numbers, because here we are trying to most probably our number of operation needed will be 0 or positive number. If the words are exact same, the number of operations will be 0 clearly. So we write minus 1, and now there is a helper function which is implementing our logic of duplicating the diagonal when the characters at the destination and source are same, and when the characters are different we take the minimum of top, left and diagonal element, and we add 1 to this minimum basically. So this is that from this minimum we are trying to find what is the minimum number of operations needed to get the previous character, and from that character we get the new output just by one more. So that's why we are adding 1. So this new function, which is a helper function, is def compute, and it takes the input I comma j. So I and j are two variables here, and I is the row index, j is the column index clearly. So if I is less than 0, if I becomes negative, so during the dp search we are updating the values, and as I just explained you, the value of the future dp is depending on the past dps. So it is likely that when we call the dp, let's say m minus 1 n minus 1, it will search m minus 2 n minus 2 and so on. So it is possible that the index becomes negative at some point. So whenever index becomes negative, we return j plus 1, and if the z is negative, so column index is negative, we return I plus 1. So this is just to handle the corner case. So we now here check the dp is minus 1. So basically it means that dp if dp is its initial value or not. If we put 0 here, we have to check for 0. So if dp ij is equals to minus 1 placeholder, we will say that we have to update the dp value clearly. So now we will compare the word character at ith place in word 1 to the character at word 2 jth place. Basically we are comparing the character by character. So now ith character in the input and jth character in the output are compared, and if they are exactly same, the dp value becomes the compute value on my I minus 1 j minus 1. So this means that the current dp value will be same as the diagonally opposite dp value, which is I minus 1 j minus 1. Okay, this is what we just went through our numerical example. And if these words are different, it means we have to look at the top, left and diagonal elements and take the minimum and add 1. So here dp ij, current dp becomes 1 plus minimum of compute I minus 1 comma j. So I minus 1 comma j is the left element, compute I minus 1 j minus 1, this is the diagonally opposite element in the above row, and compute I comma j minus 1 is the dp compute value exactly above the current numbers. Okay, so basically the compute function I comma j, compute I comma j is a function that computes the dp value, then we program array value at I comma j point. And so if we are calling compute with new operators, basically this is giving the output of dp I minus 1 comma j, dp minus j minus 1. So we see that dp at current value depends on all the past dps, at least the neighboring dps, and so we return dp I comma j. So whenever the compute function is called, it returns the dp value at I comma j, which we need. And for our bigger function, we need the number of operations to convert the complete input to complete output. It means number of operations requires to transform input, the last character in the input and preceding characters, to the last character in the output and preceding characters. and so this will be corresponding to the last index, that is the bottom right, and given by compute m minus 1 and minus 1. I'm sorry for not being able to put here this big bracket should not be there. It is in fact a small bracket like this, a small bracket m minus 1 comma n minus 1. Sorry for returning that, this is incorrect. So now, well, on the basis of feedback on some of the viewers, I'm also including here the official description of the problem from Leetcode, edit distance. So here we see that we can insert, delete or replace a character, and we have to convert the input word 1 to output word 2. And this is the same example which I took, and you can pause the video and try to do it yourself to get a better clarity. Here I am just returning, writing the code though, so it's Python code, very there's a skeleton, not so important. So these are edge cases. So if any one of them is empty, the length of other word becomes the number of minimum operations, and if both are empty, we return 0. For rest of the cases, we form a DP array with the number of rows equals to number of characters in word 1 and number of columns same as the number of characters in word 2. And we have two logic. If the words character set I and Z are same, we try to take the computations from diagonally opposite cell, and if they are different, we take the minimum of left diagonal and above value and we add 1 to it. Okay, so this is a very nice way of computing it. And so here my typos get spotted. I had in my handwritten code, I have written the big brackets here, but because this is a function which is being called compute m minus 1 n minus 1, so we defined a helper function compute, and we are directly returning compute m minus 1 n minus 1, and this is recursive call. So m minus 1 n minus 1 will depend on the previous values, and so it will be recursively called and should be small bracket and not the large bracket. Sorry for the typo. So the goal of putting this code was to provide a clear code and a working code which is free from any typos or any difficulties in reading handwriting. It is possible that some portions of my handwriting is not clear enough. Once again, let me thank you for watching this video and for your patience for going through the details and understanding it. I hope it had helped you in understanding this problem and may also help you in solving related problems. Thank you so much, and please subscribe my channel for future contents. And in case you have any concerns or suggestions for improving the video content for future videos, please leave the comment below this video, and in the description of this video I have the link to the Leetcode problem, and also I have the description of the problem, so you can just read the problem description here and follow through the things. Okay, and take care until we meet again with a new video.